Hey guys, welcome back to the Prehistoric Life Podcast, and today we have another interview. Would you like to introduce yourself?
Hey guys, my name's Sean, and my handle is birds.r.dinosaurs.
Go check him out. He posts a lot of very informative and amazing content, so please go check him out and support him.
Appreciate it.
So the basic question that I start off every interview with is, what is your favorite dinosaur?
Oh, my answer is going to seem like such a cop-out. It's Archaeopteryx. Always has been. I've had a cast of it on my walls as long as I can remember. Probably as far back as 2009, 2010, as soon as I was an adult with adult money. If you were to ask, okay, what's my second favorite dinosaur, that might be a bit more interesting.
So what is your second favorite dinosaur?
Microraptor.
Microraptor. Archaeopteryx is a very interesting stage because some people define it as a dinosaur, some don't.
Sure. Well, I think that distinction is more of a convenience rather than a denial that it is a dinosaur. I mean, it is a dinosaur, but at what point do you make the cutoff? Because there are definitions of birds that could potentially exclude dinosaurs, long tail, teeth, wing claws, things like that. But I think it's a distinction without a difference.
It's definitely some kind of in-between stage between dinosaurs and birds, though.
That's what's beautiful about it, right?
That is the agreement.
Yeah, it's a snapshot in time. And there was this idea that it's still widely regarded as the first bird. But it seems that the ancestors of birds were all very bird-like, even without being on a direct line. So all the relatives were very bird-like. And a lot of the features they associated with Archaeopteryx being a bird actually just turn out to be theropod features. So that distinction is getting more and more blurry.
And even within looking at species between Archaeopteryx and,
today, the chicken.
Birds, it gets so much more blurrier.
Yes.
It's like, I'm pretty sure when I went to the beach, I saw like that. Like,
well, I think in part it's because we take a lot of inspiration from modern animals to draw extinct ones. But what's surprising is, yes, that just all the interesting stuff actually happens between Archaeopteryx and, say, seagulls, right? That's where all the cool stuff is, like true transitional features. The fossil record from, let's say, Archaeopteryx to the bird-like theropods that we consider its closest relatives, that's actually quite spotty, like it's quite poor. And that's one of my kind of favorite areas where the contention is about, is Archaeopteryx too old to be a bird ancestor, things like that. But the fossil record after Archaeopteryx is really, really good.
Because, even within that line, they become a lot more bird-like.
Yes.
And
the one that you just went past, Ornis, is actually older than Archaeopteryx and probably one of the earliest members we know of that are on the bird line specifically. So Archaeopteryx has a legendary place for what it represents and all the debates that have happened around it and informing our understanding, but there are older relatives.
So within that line of birds and dinosaurs, which is what your whole account seems to be centered around, what in the world of paleo, what is your position? What do you do? I mean,
Great. I would class myself as a science communicator because I feel flattered that you had asked the question that I would be in paleo. But honestly, I'm a lecturer of mathematics. My training is as a qualified teacher and as a mathematician, and paleontology has always been sort of my love, the subject I would have loved to do if I didn't have to go where the money was. Life's currents take you in a certain direction. With math, at least you've always got work. Sure, people will always hate you, but they'll still pay you to hate you, which is great. But I consider myself a science communicator. I feel like my strength lies in I've been reading the papers for a long time. So I started reading papers all the way, not in 1984. I wasn't around, but from 1984. I've been reading those because I was really interested in how thought had developed towards accepting birds as dinosaurs. So I just like to bring maybe the technical things that people don't necessarily get or see, and make those accessible. And I hope that that's what I'm doing with my channel.
and I mean, even within that, you're talking about the side that's even a little more less known, because not that there's anything wrong with it. The vast majority of the population, if you ask them, hey, what is a T-Rex? They could probably jot down a general picture and tell you general facts like, oh, it's got a strong bite force and it's this massive predator that lived in the time of the dinosaurs. But like, you start talking about some of these lesser known, farther on species
Mhm.
that kind of don't get that popular attention, especially past, like, not that there's anything wrong with like Archaeopteryx, but like Archaeopteryx still has a lot of spotlight, but the stuff around it, it's just
Absolutely. Yeah.
no one talks about it.
And I think it's because rather than making the picture clearer, that's where all the contention is. And again, there's nothing wrong with that. But a lot of these relationships around Archaeopteryx aren't really resolved as to what's on what line, because all of these early Pyravians, as they're called, the relatives of birds, it seems that they were all ancestrally more bird-like. So Anchiornis, for example, and Microraptor, they were more bird-like, and people tend to think, or at least the general story was that, look at Velociraptor, look at Deinonychus, they're very theropod-like, and look at Archaeopteryx, it's more gracile, it's smaller, it's feathered, all those kind of things. But it turns out that it looks like the early ancestors of all these groups were bird-like, extremely bird-like, in fact, and that Deinonychus and Velociraptor and all of those are sort of regressions almost towards the what you consider when you think of T-Rex and theropods and things like that. Um, but what I really like to get into is, yeah, like you said, people know T-Rex, they know it's a large predator, they know, but everything's part of a larger group. Tyrannosaurus rex is just a species. You've got tyrannosaurids. You've got large ones, small ones. It really kind of, I want to remind people that these creatures, they come from somewhere, you know?
I mean, it's also a very unique area is talking about that, because it's also very, like you said, the line is very blurry. It's at some point you have to start looking at just individual species, and you just like, you somewhere there will probably, not today, probably not tomorrow, probably not in the next 5-10 years, there will probably be a line written in the sand again that changes everything that we know.
Yeah.
And to look at that field is
So it's,
flabbergasting. I mean, it's lack of words.
yes. And that's the thing that a lot of people criticize this about science, that, yeah, our entire picture is going to change from today to tomorrow. But the broad strokes are what I like to kind of focus on, because the broad strokes you can agree on, less debate, less contention. And I almost feel like as a science communicator, I have that luxury. I don't have to spend my life studying. I'd like to at some point, but I don't have to spend my life studying one species and then after I've described it, hoping, oh, it's going to fit in somewhere into this larger picture. I get to kind of step back and look at the broad strokes and tell a story. I feel like that's what science communication is about, telling a story. Uh, that these animals definitely did evolve. They had ancestors that were more theropod-like than they are now, and evolution's more like a bush. It sort of uh, goes out in all directions. It's not a direct line. So I feel like we're never going to have that. In fact, the more we study, the less we're going to have of that.
Because, I mean, you can just look at the theropod tree.
Yes.
It's everywhere.
It is everywhere. Yep. And keeping in mind the minuscule proportion of animals that actually fossilize, like just imagine what this would really look like through time. Like I picture it as almost 3D. I feel like you can't flatten it into this tree. But when you do, you get the overall strokes and the story. And a lot of people think that, oh, we like dinosaurs when we're kids, and you grow out of them. I grew into them. I feel like I'm growing into dinosaurs. There's things we're finding out now that I wouldn't have been equipped to understand as a child. Like there's more wonder in it now than there was before.
Because, I mean, even within the last, well, I mean, I could say 150 years, 250 years, whatever, from whenever paleontology officially started as a science or whatever. But, like, even the last 10 years, the last decade, just so much in the field of paleontology has happened. There have been so many discoveries. There's been so much interest poured into it that it's expanding. I don't know if you've heard it, but I mean, several people on this channel, if for those of you watching, you'll probably know what I'm talking about. I've referred to it as the golden age of paleontology. I mean,
I call it the molecular age of dinosaurs. Yeah.
I mean,
I like that.
The perfect time to become a paleontologist. I mean,
it is, which is why I'm gonna hopefully get onto it when I'm 40. So, yeah.
So, if you don't mind me asking, what got you into paleontology? Like, why paleontology? Why dinosaurs? Why this midsection?
Right. So, I always liked dinosaurs as a kid. Probably the same story as a lot of people. I was 5 when Jurassic Park came out. I was like, wow, look at all of that. Lots of going to the museum, but it sort of tapered off for a while. And then I wasn't really sure what I was going to do, maybe medicine or something, or mathematics, which is what I ended up doing. But in 2008, I picked up The Origin of Species, and I don't recommend it as a biology book today. You're not going to learn anything but just the beauty of the prose, and you could see why at the time it was so compelling. And while sort of reading up more on just looking for more of Darwin's works, actually, his letters and things, because I just really liked his style of writing, I came across Huxley and I came across Archaeopteryx. And beautiful. My God.
A good old copy of that one.
I recognized it as soon as you pulled it out. It's beautiful. Yes.
And even within that, that's not even the standard of the story or the theory of evolution we answer to today.
Exactly. Yeah. So when people look to it to criticize, I say, look, this is just a historical artifact, appreciate it for what it is. But that's where my interest came in, because Huxley argued that there was this close relationship between Compsognathus and Archaeopteryx from the beginning, and sort of said that if we had found Archaeopteryx without feathers, I doubt we would have classed it as anything other than Compsognathus or a dinosaur. And it was around then that it went up on my wall and I started reading into things. And even at the time, there was literature coming out, really fascinating things. So in 2004, which is when I was 18, I've just, told everybody how old I am. But that was around the time that I got into it, and where there was this big controversy around proteins and soft tissue and stuff like that. And I thought, wow, we're actually, as time goes on, we're actually understanding more and more about dinosaur biology. And then probably around 2008 is where my interest peaked, probably. And I've never kind of put it down since then. But by 2008, I was already well on the path to, doing my degree and qualifications in math. And I was just doing it as a hobby. But I actually do this now to to blow off steam. If I have a stressful day, which getting people to like you as a math teacher, that's stressful. Um, I make a post, and I'm really loving the community that I found on it. So that's kind of fueled my interest.
And I mean, that's a very unique story to a lot of people, because a lot of people, they either stick with it or they kind of get into it later on and pursue it. You're like still in that process of technically pursuing it.
Life took me in a different direction, but I know for a fact that, well, hopefully in the next couple of years, I know which colleges I want to go to. I've looked at some courses. I'll finally be at a place where I've done all the stuff I need to do for money, and I can just start really enjoying. Maybe, you never know. I guess 40 is the new 30. But I do want to get into it formally, to study it as a science, to do lab work. That would be really great. But right now I'm enjoying the conversations like this one.
And
sorry.
You've talked about how it was Huxley that got you into Archaeopteryx.
Yeah.
Could you expand on that a little more? Like, why was that part the most interesting to you, and why is that what you focus on?
It was fascinating because the notion that birds were dinosaurs was, now well underway. We're talking in the 2000s, in the 1990s. I think that was the point where there was no doubt. But my thought was, hold on, this was suggested 150 years ago. We're talking 1861, right? Or 1864, when I think the London specimen was discovered, and we could finally see that there was a tail there. And then sort of in the 1870s, there was the full Berlin specimen, and you could see teeth. And I was just like, but why? I don't understand. I didn't understand the process that 150 years ago you suggest something, but it takes until the 1990s for it to be confirmed. What was holding it up? How do you make that leap to being sure about something from a hypothesis? And that's what got me into feathered dinosaurs.
And maybe you could, what is your take on the feather kind of theory hypothesis for Theropoda, at least?
I think that Coelurosauria, definitely, just with kind of phylogenetic bracketing, we're talking at least stage 2 feathers there, right? Whether they emerged in the ancestor of all of them, there's sort of conflicting evidence there, because you've got pterosaurs, and generally if we find something in dinosaurs and pterosaurs, we say, okay, it's at least ancestral to Ornithodira, maybe even to archosaurs, right? But they have this filamentous covering, and that's very unusual for reptiles. So my take is, it's possible that the precursors of feathers were in the earliest dinosaurs. That would certainly explain a couple of things. If we go with the original Ornithischia and Serischia sort of split that's stood for over a century, then it's hard to make sense of it. But there's also the shaking up of the tree, which might make sense of why you see them in ornithischians as well, or at least in one neo-ornithischian. And I think that it's definitely Coelurosauria, but I'm quite sure that maybe at the base of Theropoda, there would have to be filamentous coverings. I think they just haven't preserved, which is why it took 2 centuries of work to kind of uncover a place and a time where you had these ideal conditions in China, in the Johol biota, where you could see these. I just think they haven't preserved. And for T-Rex, a really large animal, we know that most of the skin that we do know has scales on it. But look at elephants. When an animal gets large enough, its problem isn't staying warm, it's staying cool. So you'd expect it to not have a covering, but I don't think that we have enough resolution to know if it had a sparse covering. So large theropods, probably scaly. Early theropods, probably fuzzy. And the fact that Eutyrannus is completely covered, that tells me that came along way before tyrannosaurs evolved. So I think feathers are something fundamental. So today, if you see a feather on the ground, you know for a fact that it came from a bird, right? It's fundamental to what they are. But say that you went back 66 million years, working on that, by the way, uh, you would, mathematician and all, there's got to be something good about it, right?
I figure out the math of time travel.
Yes, but I think that we wouldn't be so sure if we saw a feather on the ground.
Could you mentioned like stages of feathers within evolution? Could you talk about the stages of feathers?
Yeah, absolutely. So stage one is just this protrusion that is probably a modified scale, right? Sort of like a hollow tube. Stage two, I've done a post on that one where there's this light branching pattern. And it seems that the rachis, the central shaft, didn't evolve until considerably later. And it probably only evolved in dromaeosaurs and troodontids and sort of more derived theropods. So it seems like my take is that if you look at, there was this finding in amber. I don't know if you saw the post, but I was really fascinated by amber fossils because they've got this unprecedented insight because of how clear the fossils are. But you're also limited by size because you can only get tiny fossils. So it's going to be baby dinosaurs or pieces of dinosaurs. But those feathers are different to any feathers that you see today. There, thank you. Yeah, that one. So those feathers are different to anything that you see today. And that either implies that ancestrally, feathers either looked that way or we're looking at a completely different type of feather. And both of those things are great because if it's the first one, great, we know something more about the origin of feathers. If it's the second one, even better, because that tells you that the feathers in birds are a subset of total feather diversity in dinosaurs. I think that just strengthens the hypothesis for their placement there.
And of course, later on, they keep evolving or so, and then we get modern bird feathers.
Yeah, but here's the interesting thing with evolution, and again, with Archaeopteryx, we're talking the most advanced feather form is the pennaceous feathers. You know, the ones that you would look at and say undeniably that's a feather. And there was this notion early on that evolution was, I would say it's still a gradual process, but that all of these features kind of evolve in tandem. You get something that gets less and less bird-like, or sorry, less and less theropod-like, more and more bird-like. But fully pennaceous feathers are there 150 million years ago. We're talking ancient, which means they must have diversified way earlier. But all these other features are lagging behind. There's still the tail and the teeth. There's this mosaic.
And I mean, you're talking about like 150 million years ago. That's even like before the Cretaceous. That's before Tyrannosaurus and Velociraptor. I mean, that's
way before. Yeah.
That's the Jurassic period. Like, that's a huge time in, I mean, diversity of that. So I mean, it could be that since there is that open niche for kind of like
research,
Archaeopteryx probably wasn't competing with dinosaurs, but most likely probably pterosaurs. I mean,
right. So powered flight is extremely rare. There's only 3 groups of vertebrates that have ever done it. And you're right, it doesn't seem like Archaeopteryx or even birds later on, because bird diversity was also quite large, you know, during the Cretaceous at the least. Not so sure about the Jurassic, but it seems that they were occupying a different niche. They weren't competing with each other.
I mean, it's powered. Yeah, like you said, powered flight is not common. It's not a common thing. So the likelihood that early on and that beginning of like the stage, that they would be able to power fly like that from that early on is very unlikely. But their ancestors who probably survived mass extinctions and things like that, well, they are definitely flying. Not were, they are. Like,
Yeah, so the origin of flight is just one of those really fascinating things. And it's fascinating for me because we don't yet know whether it was ground up or tree down. Are we talking arboreal animals like Microraptor has clear adaptations for living in the trees? And, at first we thought it was a good glider, and it was, but now it may have actually been capable of some powered flight and sort of equivalent to Archaeopteryx, but evolved completely separately. So there must have been this pressure early on for Pyravians to diversify into this because they're already tiny, they're already feathered, and they've got this airfoil, arms and legs. So flight was being experimented with very early on. There's even evidence now that Anchiornis, more ancient than Archaeopteryx, might have been capable of some flight, which again would have been independently evolved. So we're talking multiple innovations of flight, experimentations, and there was just one lineage that kind of made it through the bottleneck.
And I mean, you said Pyravian dinosaurs. What distinguishes like a Pyravian dinosaur from like other theropods?
Okay, fair. Yeah, so Pyravians tend to be smaller. They're feathered. Many of them do have that classic claw of theirs. Um, the distinction early on, whether we're talking Pyravian or avian, is really, really difficult. It's only when you kind of get past Anchiornis to things that definitely aren't birds that you can make that distinction, but they're just extremely bird-like. So they've got propatagiums, which in modern birds, kind of like in this area here, is crucial for flight, but they clearly didn't use it for that purpose. So bird-like.
And I mean, it's you talked about how they possibly are talking about how Microraptor could possibly fly. I'm not going to say anything definitive because theories, testing, all that, science. What are the tests that you would perform to kind of?
So the main one that I've read from my reading is flapping ability, because the ability to flap would have to precede flapping itself. And it's rarely the case that these features evolve. So things don't evolve for a purpose. They're there and then they get kind of co-opted for that purpose. So all of the features that we look at birds and think, oh, wow, those are so optimized for flight. Yeah, they've been refined, but feathers themselves are crucial for flight, but they occurred long before there was flight. So the main tests are flapping ability, whether they're lightweight, whether they could hold their arms a certain way, were they ground dwelling, so they look at the feet quite often, and we find that the feet of these theropods aren't really adapted for perching. So it's likely that many of them were spending a lot of time on the ground. Now, whether that means that flight was ground up or we're missing something that it's top down, I don't know. I don't think anybody does at the moment definitively. But flapping ability, whether they're light enough to do it, the mechanics of it are what they test.
And what would like some of the skeletal adaptations in Pyravian dinosaurs suggest about like flight or like gliding ability?
So flexible wrists is one. Strong sternum is also important for flight because that's where the muscles attach. If there isn't a strong sternum, there's no attachment site for the muscles. There's no powered flapping. It's also the way that the shoulders would fit, which can often be quite speculative. How does the shoulder move within the joint, especially when you're talking about limited fossil material? So it's those things that they would look for. Pneumatization is actually quite common in theropods, so you can't really use it as a metric for flight ability. But mostly positioning of limbs, muscle attachment sites, and stability. So the thing with flight is that it's really stressful, right? I mean, flapping is very stressful. That's why the fingers of birds are fused into a single bone, because it provides, imagine that you're doing that weird thing people do with their hands. I could never do it. My students do it quite a bit, right? It's where your fingers kind of smack together. Like that hurts, right? So
Yeah.
that's why the fingers of birds are fused together. So they look for things like, are the fingers held in parallel? Is there any sign that they would have been encased in skin? So for birds like ostriches, you've got very prominent wing fingers, but there's a padding, a covering. Those aren't exposed, they're underneath. And there's some evidence that Anchiornis might have held its fingers in that same way, which is an idea that those limbs are already adapted for flight. And finally, the last thing is the proportion of the limbs. So we are bipedal mostly, right? And our legs are longer than our arms. Most animals that are quadrupedal tend to have legs that are about the same size, but the back legs are slightly longer. In Pyravian dinosaurs, particularly towards birds, the length of the arms is way out of proportion. Yes. So they weren't using those for anything other than flapping or gliding.
And you talked about, like, I think balance in there. Are there what role did, like, the tail play
So
in balance or flight control?
so the tail was there. It's an ancestral feature, and it was also entirely covered in feathers for most of these animals. Now, there was this in 1915. It was suggested that birds went through this period in their evolution where they had this tetrapteryx stage where they had back leg feathers, which is quite well supported now. But really, some people argue that it should have been a pentapteryx because of the tail. So it certainly would have provided a foil. Maybe it would have been used for steering, but I think that was one of the first things to be reduced. I think it gets in the way mostly.
And what was, like, the primary environment for Pyravian raptors, or not raptors, but dinosaurs? Because pterosaurs they were powered flyers. They could fly. We
Global distribution, yeah.
know they could fly now, and
Yeah.
so they can kind of get anywhere they need.
Yeah.
But Peruvian dinosaurs are still debated. They're a little smaller. They probably can't migrate halfway across the planet if they need.
Absolutely. So, in terms of environment, I mean, we're talking diverse environments here. We're talking uh, animals like Velociraptor living in more desert type conditions. And then we're talking like animals like Anchiornis living in forested Cretaceous of China, for example. And so there's no one environment you could say. So, sure, early on in the evolution of dinosaurs, there wasn't much diversity simply because the continents were closer together. But as they drifted apart, so did their environments. So, as far as I know, so I don't want to say anything that I don't know, but as far as I know, that their environments were quite diverse. So, it's not that they were all forested or they were all deserted. Anchiornis, I know, lived in a primarily forested environment. Velociraptor lived in a desert environment. Probably everything in between.
What are some, like, predator-prey relationships they would these Pyruvians would have?
Wow, I love when behavior is fossilized. It's that thing that adds a new dimension to the animals, and the generally finding fossils where behavior is preserved is difficult compared to just finding. So you tend to see when animals die and get fossilized, they're the ones that have been scavenged and torn apart. So it's not really predator prey, but I would say the fighting dinosaurs, right, is just a legendary sort of battle that's been immortalized. And I think that they were likely loners. Maybe they were weakly social. There's no evidence that there was actually early interpretations. Ostrom himself, when he was studying Deinonychus, said that some of the things were difficult to explain if they weren't pack animals. But since then, it's been found that they're either solitary hunters or they're weakly social. So it would have been maybe stalking prey, maybe running them down. They were definitely adapted for running. So they could chase. And they were also very agile. And you can kind of see from the fighting dinosaurs that it's grappling with the animal. It's grabbing onto it with its arms. It's using its back toe to stab it in the neck. I would say they were active predators, but not pack animals.
And I mean, about building on that thing, I've heard that they're probably more like wolves in the sense where they will be together, but most of them would probably rather hunt alone than
Yeah,
together unless the
weekly,
prey was big enough.
exactly. Weekly social, but there might be advantages to getting larger prey. But Velociraptor itself, it seems like it was hunting alone that day.
And you were talking about behavior being fossilized. I don't know if this was recent. I don't
Yes,
know
this
when
was
this was.
recent. Yeah.
Yes, the pterosaur that was found with plants in its stomach.
Yeah. First confirmed herbivorous pterosaur.
So I mean, like, if that's the case, were there other herbivorous pterosaurs? What are some?
So
Was
I
it
have
completely herbivorous or like what
so
is
I
it?
haven't looked into pterosaurs, I'll be honest. I only look at them tangentially to see what features were ancestral to the group for dinosaurs. So I'm interested in what early dinosaurs were like. And so, the ankle joint of pterosaurs and dinosaurs is the same. They have that hinge ankle. So at least ornithodyrans were like that. I don't doubt that they were extremely diverse and they had diverse diets and niches, but I would say sure.
And I mean, obviously, I mean, an animal can be omnivorous, and to an extent, all animals are omnivorous.
Yeah,
There's
I would.
no real strict one or the other because I mean, that we see cows and deer in the modern age eating like snakes and tiny birds and things.
That's exactly what I was going to say. I was really freaked out when I found out that
Oh yeah,
deer, yeah, can eat birds and squirrels. I was like, okay, that's my childhood completely shattered.
it's like nobody teaches you that Bambi is out there
Exactly.
devouring
But it makes
little
sense
tiny birds.
because protein is good. If they can find a protein source opportunistically, they'll take it.
And then even within the other side of that, they are more heavily herbivores, so they still get most of their protein from plants and things like that with special bacteria and things in their gut, and that helps
Yeah,
them
long guts, chambers. Yeah, they're
do
adapted
whatever.
to lifestyle. It's very hard to be generalist and to kind of straddle that line. I mean, there are animals that do that. Raccoons are a good example. Uh,
Bears.
bears, exactly. So there is a gradient of sort of niches, but specialization usually helps you survive in a certain environment.
And that's why generalists like that tend to probably that they would probably survive more
Yes.
abundantly in other places.
Yeah, I would say it really depends. Like if you're a generalist, then by definition you're flexible. So you could adapt into different niches. But I think that it was the fact that birds, our lineage of birds that we see today, ornithomorpha, were extremely specialized. And I think that's probably why they survived.
And in your opinion, I mean, within that generalization, is it a possibility that because obviously there wasn't as much plant life. Well, I don't want to say that. There's different plant life between now and all the way back in the Cretaceous and the Jurassic. I mean, grass
It
wasn't even
very
anything.
different. Exactly. There would have been
So
no grass, flowering plants,
for
angiosperms came to,
Cretaceous
yeah,
and
they
late
started
Cretaceous.
to, exactly. They started to diversify around there. So it would look very different.
So, is there a possibility for there being kind of maybe not completely herbivorous but omnivorous uh, Pyravian dinosaurs?
Sure. So the thing
Or-
with theropods is that fundamentally, ancestrally, they had adaptations for hunting and eating meat. There are certainly exceptions in theropods that were clearly either herbivorous or omnivorous. They did. I would say sure. Like it's speculative, but it seems like given their sharp teeth and their small size, I don't see much room for long guts. I think they were specialized predators, most likely.
Um, and within that, what is the most like significant fossil discovery of Pyravian dinosaurs to date, in your opinion, and just in general?
Oh, that's a good one. Okay. For me, I would say that Zulong was probably fairly recent, and it was. I think I told you about how I wondered why it took so long to kind of accept that birds are dinosaurs and that there is this clear line of descent for 150 years, and it's because we want to know just how different birds are from their proposed ancestors. And Velociraptor has quill knobs on its arms, so you can infer feathers. And phylogenetically speaking, I think you can say with certainty that it was feathered, but it hasn't been found feathered. Zulong is 1.6 meters, about the size of Velociraptor. Yeah, closely related. Definitely didn't fly, or very unlikely, but it's got this big wing, you know. And we're talking, okay, feathers like that were ancestral to the whole group, and they all had them, even Deinonychus.
And I mean, I feel this is just me talking. Deinonychus would be a very powerful option because that was kind of one of those first dinosaurs that really was like, whoa, wait a minute, these aren't all lizards.
Yes, that it started the whole thing, and I think it was the first member of that group identified with that sickle claw. So that's what made Ostrom think in the first place that okay, we've got something different here. That's my understanding of it. Somebody can fact check me, but obviously many have been discovered since. But it really did set it off, and I've tried to read through the whole monograph, this strange theropod from the Cretaceous, Deinonychus, and I'll be honest, I haven't gotten through all of it, but I was interested in just how much of the fossil material is known. Some of the skulls are actually probably not accurate reconstructions because we didn't have the full material. I was really curious about all that, but yeah, definitely the features that made it look active.
As for the sickle claw, it was. I just didn't. It was good to know.
Beautiful. I think it's a beautiful adaptation.
And I mean, you're talking about how like technically the book's outdated now.
Oh, sure, yeah.
But it's also like if you look at it for the time, for what they knew, he's doing some pretty major breakthroughs. Like
the extent of their inference, their inferential abilities is to be admired.
And that's kind of one thing I will, because I already have my own quarrels with scientific papers and them not being easily accessible, not even like actually accessible, but like
paywalls,
knowledge-wise accessible to the general public. But so I already have my quarrels with scientific papers, but for the people that look at a scientific paper that's like 100 years old and they're like, oh, this is stupid. It's like, oh yeah, it's probably stupid now, but like 100 years ago.
We're talking cutting edge at the time. You have to respect the efforts of the people at the time working with what they had. It's very easy to look at what we know now and think they knew nothing. But sometimes I think that the sort of reach of reason that people like Darwin had based on the evidence they had, I don't know if I've seen much of it today.
I mean, it's you gotta take the time to look at what was going on during that what was available. What challenges exist in interpreting like soft tissue impressions in fossils?
Right. Well, I think the biggest challenge is that there's not much of it. And what will happen is it's not usually visible to the naked eye. So you can tell where there's some soft tissue preservation because of outlines and it's not just pure bone in the matrix kind of thing. But some challenges are that, yes, we assume that they had similar biology, that they had the same heart that birds do, but they could have had plenty of unique adaptations that we just wouldn't recognize looking at them. So one of the big, what I found is when papers get summarized, they talk about it with a lot of certainty. They say, oh yeah, this is definitely part of the gut and there's this amount of food or this animal in it. But then there'll be somebody else that interprets it as something completely different. There's still people making arguments that we haven't really found feathers in Sinosopteryx, that they're collagen fibers, which I think there's no weight to that now because we know the color. We're way past is it feathers? Yeah. But it's there. Yeah.
But I mean, and of course, the obvious thing is preservation bias.
Yes.
Smaller dinosaurs already don't fossilize as well as the giant titans of their time, like Tyrannosaurus and the sauropods and ceratopsians. They don't. You like you can test this out. Put a pencil on the ground, put a giant pillar of stone in the ground, and see which one decays faster. It's pretty
Absolutely.
obvious which one will decay faster.
Yeah.
And so that preservation bias already leads us with a very fractured understanding of them because we're missing most of them. On top of
Yeah.
on top of excavation mishaps are possible.
Yeah.
Destructive sampling is sometimes necessary, and then if you mess up that, so it's very easy to get lost along the way and lose
details, or it could just be open to erosion. It becomes revealed one day, you don't get to it in time, it's gone. Yeah, it's gone, just like the rock that was over it. But I found that preservation bias really does affect people's understanding of what dinosaurs are, because one of the biggest questions I get, it's a really common question, is, okay, but if they're dinosaurs, how did they get so small?
So I mean, could you talk on that a little bit?
Sure. I just tell them that there were actually very small dinosaurs. There was an entire continuum of large theropods to theropods that were between 100 and 500 grams, like Anchiornis, and that birds are descended from the tiny ones. And also the fact that size changes drastically in evolution. There used to be this idea that all the large theropods were more closely related to each other than to other groups. But it seems that all of them, Allosaurus, Tyrannosaurus, they all evolved their large size independently. So size changing in evolution, look at the largest bird that ever lived, the elephant bird. Its sizes can vary. So I say that there were small dinosaurs.
Yeah, I mean, even within that, like, I think a big misconception with that is that somebody's just like, all right, you have T-Rex, and then like 400 years later, boom, you have Archaeopteryx. It's like, no, that's it. Yeah. They're two completely different lineages. They're not even. They are related, but not directly related.
Yeah.
And on top of that, whatever species that evolved into Archaeopteryx had to go through the entire Coelosaura, then the Maniraptor forms, then not choose to turn into compsognathids, not choose to turn into ornithomimids.
Right.
And then it just keeps going and keeps going until you get to Avelia.
It gives the illusion of a straight line.
It does. I mean, but like even within there's interspecies there that it's not just like a clean slate basic theropod that's like medium size that either got really big or really tiny.
Yeah. There's also this idea that there is some disparity between the largest theropods and smaller ones on average. And the reason for that might be that the dinosaurs lived relatively long lives. It really depends on them, but especially the large ones, fast growth rates, but they didn't mature until they were 15 years old, which is, unheard of for their descendants here that are birds. Like, they mature in days, not in years.
Yeah.
And it's very possible that the young and the adults occupied different niches so that they didn't get in each other's way. And that would account for that disparity in size.
Because, I mean, we talked about Jurassic Park originally. I mean, you can look at the original book, not necessarily the movie. The movie has its differences from the book. But even in the book, the main, like, chasing force isn't the adult T-Rex. It's like a juvenile.
It was exactly right. And Crichton didn't want T-Rex to be the big bad, so to speak, of the movie. He wanted it to be the raptors. I mean, that's a whole other thing if you want to talk about it. The changes that the raptors went through, not just between Ostrom and the book, but the book and the movies. I'll say that Jurassic Park, it gets a lot of criticism. Jurassic World, you know what? I don't even watch them. I just don't. I don't know where to start with those. But Jurassic Park 1 and 2, masterpieces. As long as you don't take them as a documentary,
that's a whole different can of worms. I mean, it's not. It's portrayed for purely entertainment purposes. It's not a documentary.
It's
so
a monster.
People who are like,
yeah,
it's a bad documentary. It's a bad interpretation. It's entertainment. Shut your brain off a little bit, just a little bit, and then just like
I say, it's a monster. Enjoy the monster movie. Yeah.
I mean, even if you actually read the book and look at the times, the raptors in the book and in the movie are actually based on Deinonychus, which for the time was actually referred to as Velociraptor.
So you're right.
Technically inaccurate.
Yeah. So it was, a lot of those justifications in my research are retrospective. So yes, they for quite some time they weren't considered as distinct genera, but that wasn't the reason that it was named Velociraptor rather than Deinonychus.
Yeah, I mean,
Crichton, as a matter of record, said to Ostrom, you know what, despite his advice that even then, you're modeling Deinonychus here, you should call it that. He said, I've decided to go with Velociraptor because it sounds cooler. So,
still, I mean, there's a lot there, and it's not portrayed as a documentary. It's for entertainment, so be entertained. Just let it entertain you.
Yes, compromises were made.
It's also like, especially for the movies where people are like, honestly, in my opinion, I would give the book more slack than the movies because you can just write an extra sentence and describe everything.
Yeah,
that's a possibility. For the movies, there's budgets, there's people you have to pay, you have to actually make it visually appealing, and then on top of that, can you even afford to make it visually appealing? So there's so many changes that need to be made to make it that.
Yeah, I say people to please and people to pay. Yes. So a lot of compromises were made for the movie, and the Raptors, so to speak, they went through some changes as well. So
very much so.
Yeah. So Crichton wanted them to be scary. So Deinonychus certainly wasn't 6 feet tall, but in the book he makes them about 6 feet tall and 180 pounds. And then Spielberg comes along and says, you know what? I want to make them even bigger. I want to make them taller than a man. And they did. And people say, oh, it's actually based more on Utahraptor. I say Spielberg says they got lucky with that one.
Yeah, Utahraptor was found like right after the movie was released. Like,
yes, and the raptors had already been designed by the time it was described in '93. So Spielberg said, yeah, we got lucky. Now we can say it's Utahraptor, but no, they're just movie monsters.
They're also movie. And again, like I said, it's a whole other can of worms. They even did like talk about it in the movies, where they talk about how they have to gene splice it because you can't get the correct genetics. So it's not even an actual dinosaur to begin with. And even you said you didn't watch the Jurassic World movie. There's a whole line that Dr. Wu says in that movie. He's like, we don't have complete DNA. If we had complete DNA, they would look more realistic.
Yeah, I've seen memes of that. Yeah, these animals would look quite different. And I agree with that. I think that was actually there as a device so that it could actually protect against future discoveries. I mean, those movies were well thought out, okay? And they brought dinosaurs to life, I think, in a way that nothing had before. I think a lot of people, the love of dinosaurs was spawned in those movies. But take it for what it is.
So it's like, to me, it's like an unjustified hatred for the movie. It makes no sense to me. And it's like, oh, well, they're not accurate. And it's like, okay, well, let's look at the target audience, the general public who does not have this advanced paleontological understanding of the world, who just wants to be entertained by a movie. Do you think they care? No? Then shut up. Like,
listen, if you had little turkeys chasing the kids, do you think people would want to see that little turkey-sized dinosaurs?
It doesn't make a compelling story, and there are very and I mean, even realistically, Tyrannosaurus would not hunt people. Like,
probably not.
We would probably, I mean, if you messed with it, it would probably attack and defend, and kill you, and then I mean, since you're there, they'd probably eat you. But like the realistic size to calorie range, it's just not there. It wouldn't
Worth the
actively
effort.
harm people.
Yes. Yeah. It probably ignores time your prey, to be fair.
And I mean, again, I probably, if anything, would give the book more flack than the movies, simply because of design choices that have to be made, budgets and money and people to pay.
And plus, in a book, when you're reading it, you can imagine what you imagine from the book is going to look different. But
Yeah.
compromises did have to be made. But here's the weird thing. They tried to do their best in accuracy. I think this is where a lot of it comes from, because they try to do their best in certain parts and they do really well. And then they go all out on these raptors that can open doors and hunt in packs and study you. Like Crichton said that when they looked at you, it was like they were studying you. So I stand by, they were movie monsters, right? They were never really dinosaurs, but hey, it was a great movie.
And on top of that, it's like, okay, let's look what this movie has done for not even the general public, because for the general public, it's become a masterpiece and an entertaining movie that thousands of millions love, millions, not even thousands. I could probably go as far as to say billions, but that might be a little bit of a stretch, but probably not. But still, it put paleontology in the forefront as an idea of a possibility that people can go into as a career. It inspired so many people to the point that it is up there as like one of the top reasons, probably one of the like top 3 most common reasons that somebody became a paleontologist.
Yes, I absolutely agree. We should be thanking it for that matter, because look, the hero of the movie is a paleontologist. It made paleontology attractive. You know, I loved the idea when I watched it of excavating dinosaurs. That's when my parents started to buy me all these books, these DK eyewitness books, and the raptors in there were, modeled after the movie. So that movie had a huge effect on, just because they looked so cool and the efforts they went to. People were like, okay, that's how we want to represent these dinosaurs now to kids. But yeah, I wouldn't go to it if I wanted to know what dinosaurs behaved like or looked like or what they did.
I mean, it's, and I guess the only thing I would strive for the movies is from here on out to try to appeal to some paleo accuracy. But like, I get you also need.
It's getting worse. I think that ship has sailed.
But if you look at like a paleo accurate Gigantosaurus and a paleo accurate T-Rex, like there's, if you put them side by side in a dark room, you probably couldn't tell them apart. Like,
yeah, so Giganotosaurus is, people get annoyed when I say it was larger than T-Rex. Look, I understand that when you say larger, you're talking about the mass, and T-Rex was super massive, and therefore it was larger. But to the eye, it's probably longer. So there's some contention there because of incomplete specimens and, range among animals. We're talking a difference of like 3 feet here. So
yeah, and I mean, I feel like it's one of those situations where it's just like kind of just unnecessary malice.
Pick your battles, I say.
It's like you're really gonna die on the hill that Jurassic Park's a bad movie because it's not paleo accurate. Like,
yeah, I think a lot of that comes from, hey, look at me, I know real dinosaurs kind of thing.
It's like a weird pick me kind of persona.
Right.
It's so weird. Because it's like, oh, counter argument. I also like dinosaurs. I also like the movie. Like, what's your point?
People tell me, hey, you must be fun at parties. And I'm like, you know what? I am fun at parties. And I don't spend most of my time talking about the differences. When I do that, I do it to help people enjoy the movie more. It's not an attack on the movie. Understand the compromises. Enjoy the film.
And even on top of that, that's not even like an actual valid criticism of the movie.
Yes.
Because unlike okay, let's use this example. 65. Everybody hates that movie. And here's the thing. From the paleo side, yeah, there's valid criticism that Those are not dinosaurs. They are way far off. They know better.
Yeah.
What in the WTF? Like,
is that what they were going for, though? Is the question.
But then even on top of that, like, okay, let's look at it from a movie standpoint. It's still a bad movie. The story's not compelling. The characters aren't compelling. You have all of these other attributes.
Loosely connected violence, I'd say.
Yeah, like there are other attributes that make it a bad movie other than like, oh, the designs are bad.
No, absolutely.
But I digress. That's a whole different
It's a whole conversation. It absolutely is. Yes.
So that's a whole different conversation that deserves a whole nother video all by itself. So let's circle back to Pyravian dinosaurs. And you mentioned how what is it? Not Eoraptor. One of the Microraptor. I don't know why I was blank on that. And how it lived in China. Like, how are the fossils from sites like Liaoning, China? I probably horribly.
It's Liaoning province, China. Yeah.
Reshaping our understanding of like feathered dinosaurs.
So there was this book, this really great one called Feathered Dragons, and it was all about the fossils coming out of China, and they really did revolutionize our understanding. I think it made it firm and clear that feathers were a theropod thing, or at least a Maniraptoran thing, or a Coelurosaurian thing. And if something so fundamental to birds is in dinosaurs, then surely there's a close relationship there. But it wasn't just the fact that you've got these feathers preserved. It's the sheer diversity, this snapshot in time that you've already got these animals. They're already well underway to what we would recognize today. And they're diverse and they're dispersed. And, what we're looking at today is this triangle, this closing triangle of diversity that existed in the past. So birds are dinosaurs. And I can only say that's like our biggest insight.
And I mean, especially with that discovery of like feathered creatures there really does help.
I think it absolutely says that there should be no doubt on the theropod ancestry of birds.
And was an older interview with my professor, Dr. Persons. If any of you who are watching remember that one, he said like we're still in the modern age where people think it's the like answer, the conservative answer is to like dinosaurs had scales unless proven otherwise, but it should be the other way around. Dinosaurs have feathers until it's proven otherwise.
I like that. It really depends on which branch you're talking about, but I would definitely go with that for Coelurosauria. If there's scales, it's likely that either the covering didn't preserve or it was lost in multiple lineages for whatever reasons.
Or even possible like age differencing. I mean, it's even with Tyrannosaurus. I mean, T-Rex, like the adult, doesn't necessarily have evidence of feathering, but that doesn't mean that the younger, smaller ones didn't, and they lost it as they grow older due to the lack of needing.
If you can shed down feathers as a bird, you can shed feathery coverings as a T-Rex. And I think life stages are one of those things where we don't have them for so many dinosaurs that we'd like to. There's probably different. I mean, that there are life stages that people argue, is it a distinct species or a life stage? Jack Horner said, I think back in the 2000s, he was like, we were finding all these big dinosaurs and we started to wonder where are the little ones, and it turns out that these aren't different species, they're life stages kind of thing, where the babies basically saying, he was saying, where are the juveniles for these animals? And it's like, you're looking at them, you're just calling them different species.
What controversies exist over the clarification of certain species as like birds versus non-avian dinosaurs?
So I would say that the controversies lie at the base of the tree. So the closer you get to the base, that ancestor, the one that branched off and would eventually become what we call avian, the avian line, and the Pyravian line and all the parallel lines to it, at that moment, somewhere around 160 odd million years ago, they would have been identical. So even if you found them, that level of resolution, I don't think is possible in discerning. With Archaeopteryx, even, yes, it's widely considered to be the earliest member. Well, not anymore, to be frank. There's slightly earlier ones, say from 160 million years ago, 10 years earlier than Archaeopteryx. But we say that, okay, that's one of the earliest confirmed members of Avialae. But I think that at the base, it would be impossible to tell almost. If you're trying to find one feature, I think for a while the feature was flight. So they said that, okay, we draw the line at Archaeopteryx because we believe it has some flight ability, and only one lineage of theropods evolved flight and took to the skies. Not the case.
And I mean, even these later ones that it is much more blurry, like these some of these seem like they could fly, especially like Hesperornis.
No, absolutely. Absolutely, they could fly. Hesperornis is probably one of my favorites. Hesperornis was not. Oh, no, sorry, I meant Ichthyornis. Sorry, Hesperornis was aquatically adapted, and it was a large bird. It was probably about 2 meters. I've got a skull, or at least a reconstruction of one. Yes, beautiful. And I've got it next to a magpie skull. I wish I'd brought it, but these were large birds. But what's amazing is there they are with teeth. They probably couldn't even move very well on land. They were aquatically adapted. Birds have been adapting to weird environments because apparently the dynamics of fluid and air are actually quite similar when it comes to aerodynamic things. So penguins kind of gliding through water is not too different to the challenges of air.
And I mean, they can get bigger because of the water.
Exactly.
Due
Yes.
to that lack of buoyancy versus the air where they do need to stay airborne. And that's the only real difference.
Yes, that's the limiting factor on avian size, the need to fly.
And even that, there are still some pretty big avian birds
Yes.
that fly.
No, absolutely. For a while it was Argentina avis, but I don't know. I think there was a larger one discovered recently. I haven't had a chance to. I've got it sort of earmarked to read, but I haven't read it, so I won't comment on it too much. But there is apparently a larger one now.
And the largest modern bird is the ostrich. And
I'm sorry, I'm talking recently extinct, but yeah, the largest modern bird is the ostrich. Yeah, they can't. They're adapted to running. Their toes, they literally have 2 toes, just because the less time it spends flat on the ground, the faster you can move. So their foot is actually really interesting.
And I mean, within that, I have some kind of a little more speculative questions. What do you think the world would look like if Pyravian dinosaurs never went extinct?
Oh man, a whole lot better. But no, I'll give a more serious answer. I honestly think that it might be more interesting, but that's sort of a fallacy, because they're only interesting because they're gone and we like to picture what they look like. But we have wondered about birds for forever. They've always been a part of our history and culture and stories. But we were literally sitting next to them on benches and not realizing what their ancestry was. So I don't know how different it would look. I think they would maybe just be another really neat animal to look at. But I'd like a world like that. Yes, I'm still. How they say, if I won the lottery, I wouldn't tell anyone, but there would be signs.
There'd be signs.
Yeah, so there would be signs. So Jack Horner's Chickenosaurus project, I'm still thinking I'm the one that's going to bankroll that one. Yeah, some point. Yeah,
and I mean, even on top of that, I think unironically they would just turn into parrots, like pets.
Yeah,
people would keep them as pets because they're small. They're
and probably smart. Yeah,
probably fairly smart.
Smart, yeah.
And then from I guess evolutionary standpoint, it's hard to say that they just went extinct
Oh, it
It's
was brutal.
each individual species has its own reason for being extinct, whether it's climate, mass extinctions, whatever. So it's hard to be like, oh, they just don't go extinct, and then like all of the other animals in that environment doesn't go extinct.
Yeah. So any particular species. So if we're looking at the species level, any particular species on average has a span of 1 to 5 million years. They're going to go extinct, right? Species change. The larger groups that contain them can go on for quite some time, but it also depends where you draw the line. So animals, we're talking every animal we've discussed today. Anything that's multicellular has an internal digestive tract. They've been around for 600 million years. So it really depends at the level. So animals have been around a long time, but Archaeopteryx was also an animal, but that went extinct fairly quickly. So depends the level you look at it at.
I think it's that question's a little bit of a loaded question because I don't think it's possible for them to just not go extinct. I
Yeah.
think the more accurate question would be like, what if convergent evolution happens and for some reason, somehow we get Pyravian dinosaurs again? Pyravian like dinosaurs.
I see what you're saying. Okay, yeah. So Pyravian like. So, I say evolution doesn't repeat, but it can definitely rhyme, right? But the problem with that is the once you've lost a certain feature, there's this limit. It becomes a limiting factor on your future evolution. So if you would to have something you'd recognize as a Pyravian dinosaur, you would have to have a dinosaur generally adapted to walking on land, right? So not a reversed hallux. So that could be done. But three free fingers, teeth, a jaw, elements of the maxilla, all of those would be. I don't think they could come back.
Yeah, it would be a lot of very, 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 very circumstantial
Yes,
environmental factors that say a pigeon turns back into Archaeopteryx.
it
That's
would
probably a
be.
bad example, but
Let's say quite literally, it would be far more likely that I won the lottery and bankrolled the project.
yeah, I mean, it's literally more likely that we could like
Do it
make
ourselves.
Archaeopteryx than it
Yeah.
naturally happened.
But I will insert a tiny bit of hope into that, right?
Yeah,
So the Huatzin of South America is I'm doing a post on the continuity of wing claws and form and function, that it's not all lost. Yes, we've got these fused bones in let's say a pheasant, but you've got this whole continuum where you've got emus with just a single finger and a claw, and a reduced thumb and no muscles in their arms, and you've got ostriches with all three fingers and claws on a couple of them. So the Huatzin has functional claws as a chick. So we're talking grasping hands here, two unfused fingers, and the third one kind of fused, and that fuses back into what we consider the general modern wing as they age. But here's the interesting thing. The last common ancestor of all modern birds didn't have that. We're pretty sure the last common ancestor had the carpometacarpus, the fused bones at the base of the finger. So this was a atavism. So I don't think the genetic mechanism's been studied, but this is like a reversion. Those claws re-evolved in that chick for that purpose. So, I think some of it could happen.
again, it would have to be a very, very circumstantial environment too.
Yeah.
But that's how most evolution works, anyways. Um, how might flight have evolved differently if Pyravians weren't the ancestors to like modern birds?
Well, I'd say they're not the ancestors to modern birds. They're sister groups, or they share a close common ancestor. How might a flight evolve differently? I think we can see how it might have evolved differently, because it did evolve differently independently in multiple lineages. But I think they start with the same anatomy as the common ancestor, and then they have similar pressures. But the more similar you are in body and form and genetics, the more likely convergent evolution is to happen, and the less likely you're able to discern that it did. So parallel evolution is like convergent evolution, where you've got these two parallel lineages evolving the same traits, but the more closely related they are, you're not going to be able to tell that it evolved separately unless you really look down at a level that we can't see in dinosaurs. We don't have DNA, for example. So I think that if you look to Microraptor and you look to Anchiornis and you look to Archaeopteryx, they all evolved flight in a similar way. What I wonder about, though, and I don't know about the flight abilities or gliding abilities of Scansoriopteryges or Idae. I don't know if you've heard of them, those bat-winged dinosaurs.
Oh, yeah.
So that might be one way that it could evolve differently, because they were close relatives of all these dinosaurs that had feathered wings, but they seem to have evolved this bat-like wing foil. So maybe like that. Evolution can surprise you.
Because, I mean, bats have that kind of, it's not feathering, it's like membrane or whatever.
Exactly. It's a membrane stretched across their fingers, and that's what the Scansoriopteridae did have.
I'm trying to find one real quick, but I don't. Yeah, here's one. This is still just paleo art that I have here of it, but this is a example of one.
Yeah, there. I've seen that one before, Ichi. I really like it. So that's one way it might have evolved differently.
And I mean, on top of that, if it were possible, I mean, pterosaurs would, keep evolving, keep changing. Maybe some would have gotten smaller, given another.
There were definitely small ones. I mean, I think the smallest one is not much bigger than a bat and it's got this really flat face. It was an insectivore, so it evolved to look like bats because its lifestyle was very bat-like.
And
but they were,
yeah, it's not unlikely that flight would still be a thing.
And a lot of people, I still come across a lot of people. Surprisingly, I come across people that say, they ask me because, you meet someone, you get comfortable enough now at work, and there's perfectly intelligent, educated people, right? And they ask me, they're like, so were dinosaurs real? We're still at that point with the science education in some cases, right? And I ask them, well, what makes you think they weren't real? But how do you explain dinosaurs to someone who isn't sure that they ever existed, right?
Yeah.
But then they think, okay, I had some students that were like, so wait, you're telling me that birds are dinosaurs, but pterosaurs aren't birds? I said, yes. And they're like, okay, cool. Yeah. But they evolved a lot of features convergently because of the same pressures. They needed wings. They needed to be lightweight. They needed a beak rather than jaws and teeth. They needed a shortened tail. That's why they resemble birds so much, because of convergent pressures.
It is kind of weird how similar all of the flying creatures that we know have that similar look to them.
I think their limitation, there's two constraints. One constraint is physics, and the other constraint is this pentadactyl limb of ours. Anything we want to do, we have to modify this guy.
Because I'll probably be calling someone out, and if they're watching this, you know I'm talking to you. I saw this thing where somebody was like, well, it's a theory that Tyrannosaurs had feathers, and they had this small two-fingered hand. Therefore, they could have had wings and flied. And it's like,
that's nice.
Hey, buddy, have you ever tried to lift let's start with 1 ton. Let's start with 1 ton. Can you lift 1 ton? More or less, can you lift it without a jet engine by flapping? No, probably not.
Yeah. No, I hear people say, okay, but if it has a wing, it must be a bird. Yeah, I get where you're coming from, because
I would say no.
I would say no, but a lot of people, So, yeah, and they're like, here's the interesting. I don't know how much you come across. Do you argue on the internet, Eric?
In terms of paleontology?
No, I mean, do you just argue?
I mean, I have, yeah.
Yeah. So I try to avoid that. My goal is SciComm, and there I am, and you talk to somebody who is really shutting you down. They're like, okay, case closed, gotcha, this and that. But then you get to the end of it and they thank you for your time and say that they'll go read something. And you find that people are just defensive because they have this idea of what you're going to think of them. So I approach every conversation I can with, you know what, I'm just going to go with it. I'm just going to go, whatever you say, I'm going to go with it and kind of see where that leads. And maybe at the end of it, you'll have been listening to something I said.
Yeah, I mean, the major thing within any debate is just like hoping that they actually listen to you.
Exactly. Yeah. And most of the time, it's probably not going to be the case. But I have had a few where I was pleasantly surprised at the end because the whole time it felt like none of this is getting through, right? But at the end, they say, thank you for not mocking me, and I'll go read on it. And you're like, huh. Oh, that's a good feeling. I'd like to do more of that.
Yeah, I mean,
yeah.
I mean, it's even within any debate, like no matter the subject, whenever it dissolves into just mockery and insults, it's not a debate. It's stupid and a waste of time. Like,
yeah,
because it's just like, okay, what am I doing? I literally have a million better things to do than just sit here and insult a stranger. Like,
exactly. Yeah. It's just more productive ways. And maybe it's the teacher in me. I don't know. I kind of, there's no sort of, very few people, very few things you could say to me that would just make me think, okay, you know what, this isn't going anywhere at all. And some people say to me, why did you give him the time? Why did you give him the space? Why did you go with it so long? And I'm like, because I'm hoping that something's getting through.
And then I guess for my for like this final kind of thought question, could Pyravian style flight evolve independently in other lineages given the right conditions?
Yes. Yeah, absolutely. So maybe I was a bit quick to answer. It's like I have this, evolution can do just about anything because what survives gets through, and there's this massive diversity, all the things that you can do with a limb. But sure, if all of the factors that help you overcome limits to powered flight, and if there are, so if you've got feathers, for example, but we find that you don't need feathers, you can have a membrane, for example. So, but if we're talking Pyravian style flight with feathers and wings, sure, maybe in Coelurosauria, maybe even feathers could evolve independently in a lineage that it wasn't ancestral to. Maybe there was ancestral pycnofibers, and that would explain why there's feathers in Neo-Ornithischians or in a Neo-Ornithischian, but it would evolve independently. So, yeah.
And I mean, even within the correct environmental conditions, I mean, who knows? Maybe another theropod-ish creature, like, because they're not technically theropods, so I am, speaking off of that, but like pachycephalosaurs.
Yeah, sure.
They're still two-legged. They're very
nimble.
Nimble like that. They could, get smaller, grow feathering. Maybe there's some kind of adaptation that they need where they need to climb. And then once you need to climb, maybe you need to jump and get away from predators still and then soar. So, I mean, it's not impossible.
Not at all. No, so with speculative evolution, I mean, that's all it is. It's speculation. Things happened a certain way, and that's what we have. But I think it's important to remember that there were lots of experimentations, and a single event could change the course of what everything looks like today, and it did.
I mean, yeah, it's a huge reason why we have birds today, which are like a big part of everything.
They're probably more diverse now than they've ever been in the past. Dinosaurs, I mean. That's one view. Sure,
I would say that's a fair, unfair thing to say.
Exactly, yes, because it's only one clade. So to say, given the diversity of dinosaurs in the past, maybe not. But then again, there's 10,000 species and fewer mammal species than that. So birds are literally on every continent now.
Yeah.
dinosaurs were. So yeah, fair or unfair, I'd say. You're right.
And I mean, even like within dinosaurs, it breaks up even more with like sauropods and
Yeah.
all like ceratopsians, stegosaurs, ankylosaurs, pachycephalosaurs, hadrosaurs. So there's a lot there.
Yeah, and it's actually quite crazy how the traits that allowed birds to become what they are actually the same traits that allowed sauropods to become so large. It's like these two animals are evolving to reach greater heights, but they're doing it in drastically different ways. One's doing it to fly, the other's doing it by getting really, really big. But neither of them could do it without that respiratory system that they both share. So
very interesting.
Things could have been different.
Yeah, we could have had flying sauropods.
Oh, that would have been so sick. Yes. Yeah.
I guess that's all the questions I have for you right now. Are there any questions you have for me or any final thoughts you want to say?
Yes. First, I want to thank you for your time, and for anybody who was here. It was a real pleasure. I won't be able to do my 5,000 follower face reveal now because here I am, but it was totally worth it. And I'd like to leave people with the thought that you don't grow out of dinosaurs. You grow into dinosaurs. And the things that we know about them today, the soft tissue, some molecular sequences from protein, their respiratory systems, those are things that a child couldn't necessarily appreciate. So there's always things to look forward to as you study dinosaurs. That's what I found. And it's also really stirring. For me, it was like re-enchantment of the world. That's what it felt like to me. It was like I wasn't that interested in birds, but I love dinosaurs. And then to find that I'd been looking at one or few every single day of my life up until that point it was like science isn't just studying facts, it's uncovering ways of seeing them. So yeah, I'd like to leave people with that there's things to look forward to in the study of dinosaurs as you get older, that you'll understand you don't grow out of them. So.
And I want to thank you for your time, for taking time out of your day to come on and talk to everybody that's going to watch this. It's always an honor to talk to people that are interested in paleontology and paleontologists. I mean,
I feel like I found my people on here, so thank you.
And I thank you again. Just it means like everything that people actually respond and just are willing to share their knowledge.
Thank you for giving me the time, and thank you to anybody who watches this. Take care, Eric.
You too, man. I'm your host, Eric Crawford. This has been Prehistoric Life Podcast. Remember, keep it prehistoric. Goodbye.